Hi everybody and welcome to Engineering and Technology's first video on American high school subjects. So today we'll be starting with chemistry. The first topic we'll be covering today is mole fractions. So let's do a quick bit of review on moles. Moles are the amount of particles that are present in a certain unit or mole of a compound. So, for example, if you have 1 mole of a substance, you have a defined number of particles or molecules in that mole of substance. And that number is known as Avogadro's number. And from past courses, you may already know that Avogadro's number is equal to 6.022 times 10 to the 32nd. Now, this is important to understand because this is how many particles are present in 1 mole of a substance. Meaning that if I had 1 mole, which when you're doing calculations can be written as 1 mole as MOL, if you have 1 mole of H2O, which is water, you have 6.022 times 10 to the 32nd molecules of H2O. So let's talk a little bit about mole fractions. Mole fractions are essentially the number of moles in a certain substance, such as mole A over moles of A plus moles of B, and so on. So what does this denote? This denotes the mole ratio between 2 substances in a compound. So let's suppose that we have 1 gram of hydrogen in our sample of water. So first we need to figure out how many moles there are of hydrogen. Suppose that none of our oxygen is in excess, meaning that we have the exact amount of oxygen needed to bond with the 1 gram of hydrogen in order to create the appropriate amount of water. So let's figure out, if we have 1 gram of hydrogen, then we can find the moles by doing 1 gram H times 1 mole over its molar mass, which is 1.01 grams. And we know this from the periodic table of elements, where 1 gram of hydrogen will be equivalent to approximately, if I get out my calculator here, 0.990 moles. And for the sake of significant figures, we can change the 1 gram to be 1.00 grams, just to make sure that we have these 3 significant figures for the moles at 0.990. So now that we figured out how many moles of hydrogen there are based on that 1.00 gram quantity of hydrogen, we can figure out how many moles of oxygen we would need to create the sufficient amount of water that can be created from 1 gram of hydrogen. So to figure this out, let's first use our mole ratio. So we have 0.990 moles of hydrogen. Now, we know that water has a chemical formula of H2O. That means that there's twice the quantity of hydrogen compared to oxygen in that molecule. So there's a ratio of 2 to 1 with hydrogen to oxygen. And we can display that in our mole ratio. We can go 1 mole of oxygen will be present for every 2 moles of hydrogen. Now, where does this leave us? This simply states that to find the number of moles of oxygen that we need to create the sufficient amount of water, we just need to divide 0.990 by 2. And if I do that, I will get 0.495 moles of oxygen. So now that we've calculated our moles as 0.495 moles of oxygen to 0.990 moles of hydrogen, we can now use our mole fraction to figure out what the percentage of hydrogen by moles is present in water. So this is actually going to be quite simple. As I said earlier, mole fraction is equal to the moles of A, which simply denotes the substance we are trying to find the percentage of, over the total moles present in the substance you're comparing. So that would just be the combination of the moles of A plus the moles of B. So we know that we're trying to find the mole fraction of hydrogen. So all we're going to do is we're going to find the moles of hydrogen, which we know to be 0.990 moles hydrogen. We'll put that over our moles of hydrogen, of course, 0.990 mole H, plus our oxygen quantity, which we've determined to be half of what the hydrogen quantity is, and thereby it's going to be 0.495 moles of oxygen. So now it's just going to be simple addition and then division. So when we calculate that out, we'll get the relatively predictable quantity of 2/3, which we could see from our addition. But in chemistry, you would, with significant figures, write 0.667, and that would be your mole fraction. Remember, for this, you do not have any other information you need to give, because you know now that the ratio of moles of hydrogen to moles present in the substance is 0.667. And so that is the quantity that you would multiply any other factor or any other problem you're doing by in order to find that respective quantity for hydrogen, because you now know its ratio in terms of moles for water. Now, in later videos, we can go over more complicated problems, such as problems that may appear on the AP chemistry exam. But this is the basic gist of mole fractions: how to derive the appropriate number of moles for the numerator, how to add them up for the denominator, and what purpose they serve. And that is the ratio between the wanted substance and the overall moles of your compound. Thank you guys for listening, and I hope you guys tune in for our future videos.